grade 3 secondary. Welcome to our maths program. Today we have calculus. Our lesson today is areas in the plane. Area in the plane means the area of a region bounded by the curve of the function f and x-axis in the closed interval a and b. For example, this function f of x equals 1 plus 4x minus x to the power 2. The area of the region bounded by this curve and x-axis from 1 to 4. To get this area, we have a very important theorem. If function f is continuous function on the closed interval a and b, and f of x, or the value of y of the function f of x, bigger than or equal 0 in this interval. That means A is the area of the region bounded by the curve of the function f and x-axis and the two straight lines x equal a and x equal b in this graph, x equal 1 and x equals 4. Then the area equals definite integral f of x dx from a to b. Example. The opposite figure shows the curve of the function f, where f of x equals 1 plus 4x minus x to the power 2. Find the area of the region bounded by the curve of the function, x-axis, and the two straight lines x equals 1 and x equals 4. Since the function f is continuous on the closed interval 1 and 4, and f of x is positive or f of x bigger than 0 for each x belongs to closed interval 1 and 4, then the area A equals definite integral of the function 1 plus 4x minus x to the power 2 dx from 1 to 4. Now, what is the integration of the constant 1? Is x. And what is the integration of 4x? Integration of 4x is 4x to the power 2 divided 2. Minus integration of x to the power 2, which equals x to the power 3 over 3, or third x to the power 3, this integral from 1 to 4. Now, the area equals x plus 2x to the power 2 minus third x power 3 from 1 to 4. We can substitute. A equals 4 plus 2 multiply 4 to the power 2 minus third multiply 4 to the power 3 between two brackets, minus between two brackets 1 plus 2 multiply 1 to the power 2 minus third multiply 1 to the power third. We can calculate the value of bracket. 4 plus 32 minus 64 over 3 minus between two bracket 1 plus 2 minus third equals 36 minus 64 over 3 minus 3 minus third, which equals 12 square unit. Then the area of the region bounded by the curve of the function f of x equals 1 plus 4x minus x to the power 2 and the x-axis from x equal 1 to x equals 4 equals 12 square unit. Another example. The opposite figure shows the curve of the function f where y equals e to the power 2x. Find the area of the region bounded by the curve of the function x-axis and the two straight lines x equals 0 and x equal len 3. First, this function e to the power 2x is continuous function in the interval or in the closed interval 0 and len 3, and f of x bigger than 0 or positive for each x belongs to closed interval 0 and len 3. Then the area equals integration definite integral e to the power x dx from 0 to len 3. Then the integration of e to the power 2x is e to the power 2x over 2, or half multiply e to the power 2x from 0 to len 3. Now we can substitute about x equal len 3 and x equal 0. Then the area equals, between two brackets, half e to the power 2 len 3 minus, between two brackets, half e to the power 2 multiply 0. Then the definite integral equals half e to the power len 3 to the power 2 minus half e to the power 0. E to the power len 3 to the power 2 can be written in the form half e to the power 9, len 9, e to the power len 9 minus half multiply e to the power 0 equals 1. The first bracket, half multiply 9, because e to the power len 9 equals 9 from the properties of len, minus half times 1. Then the integration equals 9 over 2 minus half equals 8 over 2, which equals 4. Then the area of the region bounded by the curve of the function e to the power 2x and the x-axis from x equals 0 to x equal len 3 equals 4 square units. Another example. Find the area of the region bounded by the curve of the function f, x-axis, and the two straight lines x equals -1 and x equals 2, where f of x equals 3x to the power 2 plus 1. The area is the definite integral of the function 3x power 2 plus 1 dx from -1 to 2. Now, what is the integration of 3x to the power 2 plus 1? The integration of 3x power 2 is x power 3 over 3. 3x power 3 over 3 equals x to the power 3 plus the integration of the constant 1 equals x, and the definite integral from -1 to 2. Now we can substitute in the bracket by x equals 2 and x equals -1. The first bracket, 2 to the power 3 plus 2 minus the second bracket, -1 to the power 3 plus -1. Then between two brackets, 2 to the power 3, 8 plus 2 minus -1 to the power 3 equals -1 minus 1. Then the definite integral equals 6 minus -2, which equals 8. Then the area of the region bounded by the curve of the function f and the x-axis from x equals -1 to x equals 2 equals 8 square units. Dear students, we must note that if the curve of the function intersects x-axis at x equals c, where c belongs to the closed interval a and b, show how the area of the region bounded on the x-axis and bounded by the curve of the function f and one of the two straight lines x equals a and x equals b, area A1 can be calculated and area A2 can be calculated by the definite integral. Now we have area from A to C and area 2 from C to B. Area A1 can be calculated by the rule, or to find the area, it's favorable to find the zero of the function even the limits of the integral are given. We can solve the equation y equal f of x with the x-axis. Put y equals 0, then studying the sign of the function on the subintervals if exist, then number 1, the positive part f of x bigger than 0 on the interval a and c, closed interval a and c, then the area a1 equals definite integral f of x dx from a to c. And if the sign is negative, then f of x smaller than 0 on the closed interval c and b, then the area A2 equals absolute definite integral f of x dx from a to c, because the area must be equal positive value. Example: the opposite figure shows the curve of the function f where y equals x to the power 2 plus 2x minus 3. Find the area of the region bounded by the curve of the function and the x-axis and the two straight lines x equals -3 and x equals 1. Now we have function f of x. This function is continuous on the closed interval -3 and 1, and f of x smaller than 0 or negative for each x belongs to the closed interval -3 and 1. Then the area equals absolute value of the definite integral x power 2 plus 2x minus 3 dx from -3 to 1. Now, what is the integration of x power 2 plus 2x minus 3? Integration of x power 2 is third x to the power 3. And the integration of 2x is 2x power 2 over 2. And the integration of -3 is -3x from -3 to 1. We can write a equals, the area equals third x to the power 3 plus x to the power 2 minus 3x from -3 to 1. Now we can calculate the area by substitution. Then a equals third multiply 1 to the power 3 plus 1 to the power 2 minus 3 times 1 between two brackets minus between two brackets third multiply -3 all to the power 3 plus -3 between two brackets to the power 2 minus 3 multiply -3. The first bracket third plus 1 minus 3 minus the second bracket third multiply -27 plus 9 plus 9. we can calculate the value of this integration, definite integral. We get the value equals -5/3 minus 9, which equals absolute -32/3. Then the area equal 32/3 square units. Second, area of the plane region bounded by two curves. Definition: if the two functions f and g are two continuous functions on the closed interval a and b, and f of x bigger than or equals g of x for each x belongs to the closed interval a and b. F of x greater than g of x, and the area of the region bounded by the two curves y equal f of x and y equal g of x, and the two straight lines x equals a and x equals b is given by the relation a, or the area, equals definite integral f of x dx from a to b minus definite integral g of x dx from a to b. Then we can write this area as definite integral f of x minus g of x dx from a to b. Example: find the area of the region bounded by the curve of the two functions f and g where the two lines x equals -1 and x equals 2, where f of x equals x to the power 2 minus 2 and g of x equal 3 minus x plus 1 all to the power 2. Now we have two curves, and the area between the two curves, bounded by the two curves, can be written as f of x minus g of x, and the area can be written as definite integral of 3x to the power 2 plus 1 dx from -1 to 2. Then the integration equal x power 3 plus x from -1 to 2, and we can calculate the definite value, which equals 2 to the power 3 plus 2 between two bracket minus -1 to the power 3 plus -1, and this area equals 8 plus 2 minus -1 minus 1, or 6 minus -2, which equals 8 square units. Dear students, we have an important note. When a region gets bounded by intersected curves, then the limits of integral with respect to x are the x coordinates of the intersection point. We have two curves, y1 and y2, and the two curves are intersected at 2 points. Then the limits of the definite integral with respect to x are the x coordinates of the point of intersection. Example: find the area of the region bounded by the curve y plus x to the power 2 equals 6 and the straight line y plus 2x minus 3 equal 0. In this example, first we find the x coordinate of the intersection point by putting y1 equals y2. Then we have y plus x power 2 equals 6. Then y1 equals 6 minus x to the power 2. And we have the equation of the straight line y plus 2x minus 3 equals 0. Then y2 equals 3 minus 2x. Now we can solve these two equations to find the x coordinate of the point of intersection. Then 6 minus x power 2 equals 3 minus 2x. Then x to the power 2 minus 2x minus 3 equal 0. We have expression of second degree equals 0. We can solve this trinomial equation by open two bracket. X minus 3 multiply x plus 1 equals 0. Then the value of x equals 3 or x equals negative 1. Then the area equals definite integral of 6 minus x power 2 minus 3 minus 2x dx from negative 1 to 3. Note that we write the function 6 minus x power 2, which is y1, minus 3 minus 2x, which equals y2, because the function y1 bigger than the function y2 in this closed interval from negative 1 to 3. We can check this result. Now the area equals integration of 6 minus x power 2 minus 3 plus 2x dx from negative 1 to 3. We have two like terms, and we can write this integration as definite integral 3 minus x power 2 plus 2x dx from negative 1 to 3. What is the integration of 3? 3 is a constant. The integration of the constant 3 equals 3x. And the integration of negative x to the power 2 equals x power 3 over 3 or negative third x to the power 3. And the integration of 2x equals 2x to the power 2 over 2. This integral from negative 1 to 3. Now we can find the value of this integration by substitution in this function. Then the first bracket, 3 multiply 3 minus third multiply 3 to the power 3 plus 3 to the power 2 minus between two bracket 3 multiply negative 1 minus third multiply negative 1 to the power 3 plus negative 1 to the power 2. The first bracket 9 minus 9 plus 9 minus the second bracket negative 3 plus third plus 1. Then 9 minus negative 5 over 3 equals 32 over 3 square unit is the area of the region bounded between the two curves y plus x power 2 equals 6 and the straight line y plus 2x minus 3 equal 0. Now we have volumes of revolution solids. What the meaning of solid of revolution? The solid of revolution is generated due to revolving a plane area a complete revolution about a fixed straight line in its plane called axis of revolution. We have semicircle, rectangle, right angle, triangle. If the semicircle is revolving about L as an axis of revolution, then we get a sphere. And in the case of the rectangle, we get a right cylinder. In the right angle triangle case, we get a right cone. Then the solid generated by revolving the plane area about a straight line in its plane. Now, the following figures shows some examples for solids of revolution drawn by the area A as they revolve a complete revolution about the straight line L. Now, what is the volumes of revolution? First, the volume of the solid generated by revolving a plane region about an axis, like x-axis or y-axis. We have a very important theorem. If the function f is a continuous function on the closed interval a and b, f of x bigger than or equal 0 for each x belongs to the closed interval a and b, then the solid generated by revolving the area bounded by the curve y equals f of x, x-axis, and the two straight lines x equal a and x equal b, a complete revolution about x-axis is volume equals by definite integral f of x power 2 dx from a to b. Example, find the volume of the solid generated by revolving the plane region bounded by the curve of the function f, x-axis, and the two straight lines x equals -1 and the x equal 1, a complete revolution about x-axis, knowing that the function f of x equals x to the power 2 plus 1. The function f of x equal x power 2 plus 1 is a polynomial function and continuous on the closed interval -1 and +1. We can check that f of x bigger than or equal 0 for each x belongs to this interval, closed interval -1 and +1. Let the volume of the solid generated by revolving equals V, then V equals by definite integral x power 2 plus 1, which is the function, all to the power 2. In case of the volume, we write the function to the power 2 dx from -1 to 1. Then V equals by multiply integration of x power 2 plus 1 all power 2 is a perfect square. Then this bracket can be expressed as a form x to the power 4, which is the square of the first term, plus the multiplying of the first term times second term times 2, which equals 2x to the power 2, plus the square of the second term, which equals 1. Then V equals by multiply definite integral of x power 4 plus 2x power 2 plus 1 dx from -1 to +1. Now V equals by multiply the integration of x power 4 equals 1 over 5x power 5 plus the integration of 2x power 2 equals 2 over 3x to the power 3 plus the integration of 1 equals x from -1 to 1. We can calculate the volume by substitution. Then V equals by between two bracket 1 over 5 multiply 1 to the power 5 plus 2 over 3 multiply 1 to the power 3 plus 1 minus by multiply another bracket 1 over 5 times -1 all to the power 5 plus 2 over 3 multiply -1 all to the power 3 plus -1. Then the volume equals by multiply 1 over 5 times 1 plus 2 over 3 times 1 plus 1 minus by multiply 1 over 5 times -1 plus 2 over 3 multiply -1 plus -1. then we can calculate the volume by using your calculator. Then V equals 56/15 by cubic unit. And by this example, we come to the end of our program today. And till we meet again, it's goodbye.